Good morning, everybody. Thanks for joining me. Today we will be talking about differentiation using the chain rule, a very powerful tool that can be a little bit tricky, so pay close attention. Before we jump into the chain rule, I want you to consider the following functions and how we might find the derivative of them. Our first function, 3x minus 2 squared, we can rewrite that as what? 9x squared, and then minus 6x minus 6x, so minus 12x, and then plus 4. And once we have it in that form, we can go ahead and find the power rule, or use the power rule to find the derivative. So 18x minus 12. Not too bad. Now our next example is a cubic. So yeah, that wasn't too bad when we had a quadratic, but to expand this cubic is going to take you recalling your binomial expansion, and that turns out to be 27x to the third minus 54x squared plus 36x minus 8. And once we get it in that form, it's really no trouble to find the derivative. So 3 times 27 is 81. Reduce our exponent. 2 times 54, 108. Reduce our exponent. And 36x, that's going to be plus 36. So up till now, we've been able to use our being able to expand and then find the derivative. Now with this problem in a power of 8, at this point it gets a little ridiculous. We could expand that, but at this point I'm going to say this is too much trouble. And this next one, this radical function, you could think about how you might do that for a second, but I'm going to tell you right now, given what you know now, this is impossible unless you've studied ahead. So these last couple examples are classic examples of when we would use the chain rule. So let's take a look at that. Now we use the chain rule when we have a derivative of a function that is a composition of functions. That is, we have an inner and an outer function. In that case, we have to consider both the derivative of f with respect to g of x and the derivative of the inner function. So first we find the derivative of f of g of x, and then we multiply that by the derivative of the inner function g of x. So we take the derivative of the outer function times the derivative of the inner function. A couple of other ways that you'll see these written is that you'll see g of x defined as u, and then y, or f of x, defined as f of u. So the derivative of y in that case with respect to x is going to be the derivative of y with respect to the inner function times the derivative of the inner function with respect to x. And one final way we can write the chain rule, and this is the form I'll be using in some of our examples today, is again the inner function g of x is equal to u, and then we say that y is our composition of our functions, but we can write that, since the inner function is u, we can write that as f of u. So y is f of u. Then the derivative of y is going to be f prime of u, the inner function. So the derivative of the outer function of the inner function times the derivative of the inner function. So it's going to be super important to be able to identify your inner and your outer functions. So in this first example, the inner function u is going to be 3x minus 2. And then the outer function f of u is going to be the inner function u to the 8th power. So now let's find f prime of u. So that's just 8u to the 7th power, which when we substitute g of x in for u, that's going to be 8 times 3x minus 2 to the 7th power. Next, we'll look at the derivative of u. So u prime, in this case, is going to be 3. And finally, we'll find y prime. So that's going to be, y prime is going to be f prime of u times u prime. So that's going to be f prime of u, 8 times 3x minus 2 to the 7th power times y prime. And we can simplify that. That's not too bad. In this next example, it's important to rewrite this using an exponent. So let's do that. 3x minus 2. And that's going to be to the 1/3 power. Now we should see that our inner function here is 3x minus 2. And our outer function is going to be u to the 1/3 power. So u is 3x minus 2, and u prime then would be 3. And then our outer function, f of u, is going to be u to the 1/3. F prime of u is 1/3 u to the negative 2/3, using the power rule. And then if we put g of x back into there, that's going to be 3x minus 2 instead of u to the negative 2/3 power. And finally, our y prime is going to be equal to f prime of u times u prime. And that is 1/3 3x minus 2 to the negative 1/3 times u prime, which is 3. So that's just going to be 3 times 1/3 is 1. And you can leave it in that form. In our next problem, we will again first identify the inner and outer function. So first the inner function. U is 2x to the 3rd minus 3x squared. And f of u is going to be that quantity to the 4th power, so u to the 4th power. Let's go ahead and find f prime of u. That's 4u to the 3rd, and then we'll substitute g of x back into u, so that's going to become 4 times 3x squared to the 3rd power. And u prime is going to be 6x squared minus 6x. And finally, we're going to find y prime, which is f prime of u times u prime, which is going to be 4 times g of x to the 3rd power times 6x squared minus 6x, and we're going to leave it just like that and not waste any time simplifying. You do not need to simplify on the AP exam. They know you know your algebra or you wouldn't be here.